So here's how you guys are going to be drawing Bohr diagram models of the atom. So pay attention, there's a few notes I want you to take and some instructions for how to do this. On the sides of your paper or on the bottom or on the top, somewhere where you have some notes or have some space, I want you to take some of these quick notes. Just as a reminder, the first note that I want you to take is that to find the number of protons in an atom, that is always going to be the atomic number. So write down that quick note. To find the number of electrons, negative electrons, that is always going to equal the number of protons. We're going to assume that all of these atoms are electrically neutral, which means that the number of electrons and the number of protons are equal because their opposite charges balance each other out. If you want to find the number of neutrons in the atom is the atomic mass minus the atomic number. Now, something new that you need to know for these notes is a new term called valence electrons. Write this down and highlight it somewhere around the Bohr model worksheet, at the top, bottom side, wherever you have space. A valence electron are the electrons that are on the outermost shell of the atom. Highlight that. This is going to be important for you because today you're going to fill in the symbol, atomic number, and atomic mass for each of the elements. If you have a decimal number, then you're going to round the atomic mass to the nearest whole number. You're going to fill in the Bohr models for each using the periodic table. You're going to draw small circles for each of the electrons on the correct shells. And in the nucleus, you're going to write P and N for protons and neutrons, and then highlight or color the valence electrons for each atom. And that's why I wrote VE. VE stands for valence electrons. One more thing I want you to put in your notes before we get started is the reminder that the electrons travel in shells around the nucleus, and each electron shell can only hold so many electrons. So this first shell around the nucleus can only hold up to 2 electrons. The second shell can hold up to 8 electrons, and the third shell can hold up to 18. It doesn't have to hold 18, but if an atom has that many electrons, it can hold up to 18. So take this quick note somewhere on the paper, and we're going to get started. So our first atom, let's start with hydrogen. Well, we need to locate hydrogen on the periodic table. If we find hydrogen on the periodic table, it is right here as the first element. We notice that the symbol is H, atomic number is 1, and atomic mass is 1.0079. We're going to round to the nearest whole number, which would be 1. So I'm going to go ahead and write in the symbol. The symbol is a capital H. The atomic number is 1. Atomic mass is 1. And we don't know how many valence electrons we have yet because we have to draw our atom first. So this first circle right here, that's your nucleus. So inside I'm going to write that the number of protons is 1. And the number of neutrons is atomic mass minus atomic number. Well, 1 minus 1 means that this particular atom has 0 neutrons. Now I need to draw my electrons. Electrons and protons are always equal, so I know that I have on this first shell 1 electron. Now, since I only have 1 electron, I only have 1 valence electron. That's the electron on the outermost shell. So I'm going to highlight or color that valence electron, the electron on the outermost shell, and say that there is 1 valence electron. That was pretty easy. Let's move on to helium, excuse me. Helium, if I locate that on my periodic table, is the second element on the periodic table. Atomic number 2, the symbol is He, lowercase e. You'll notice that for all of these elements, if there's 2 letters, the second letter is always lowercase. So the symbol for helium is capital H, lowercase e. Atomic number is 2. Atomic mass is 4. So I need to draw protons is the atomic number, so I have 2. Neutrons is mass minus the number, 4 minus 2. That gives me 2 neutrons. And if I have 2 protons, that means I have 2 electrons. So I'm going to draw electron 1, electron 2, and highlight those electrons on the outer shell. Oops, I need my highlighter. This electron and this electron. I have 2 valence electrons for this atom. All right, now here's where things are going to start to change. We're going to find lithium. Lithium on the periodic table is right here, number 3. It has an atomic number of 3, an atomic mass of 7 if we're rounding up. So going back, the symbol for lithium is capital L, lowercase I. Atomic number is 3. Atomic mass is 7. So the number of protons is 3. The number of neutrons, mass minus number, is 4. So there are 4 neutrons in this atom. And since there are 3 protons, that means there's 3 electrons. So I draw 1, 2, and that first shell is now full. So I have to draw the third one on the second shell. Well, now, if I highlight my valence electron, I only have 1 electron in the outermost shell, which means that in this case, I only have 1 valence electron for lithium. So beryllium is going to be atomic number 4, and then you'll notice that you're going to skip over to boron, which is atomic number of 5, because on the periodic table of elements, there's all this space in between. So you're basically going to go in order, and you're going to do all the elements all the way through argon number 18.